Alright guys, I got this one here. I'm on the test probe part of this thing. What I noticed though, if you don't have the ground hooked up, you won't get an accurate reading on this thing. Okay. Now, this oscilloscope has a frequency counter in it, a pretty good one. I think somebody told me the counter on this is something insane like 10 nanoseconds. So, let's go back over here to channel 1. And then we have to come over here, we got channel 1. Let's do the auto setup. This thing here is going to screw up. So what we have to do is we have to adjust our time base. And I need to turn off all the other channels. I don't want them on. We have 5 volts per division. We don't want 5 volts. 1.5. You see it's already reading the frequency. 1.02269 something or other. Okay, but it won't show anything here because of this times per division thing. We get, as soon as we get to 0.5 microseconds, it starts to read. It's kind of hard to make that out. It really doesn't want to focus. Okay, so that's 0.5. We go 0.2, 0.1, and then that's it. So basically, you get 0.1, 0.2, and 0.5. Everything else is dead. So that's 0.5 seconds. I mean, that might actually work, but it's not. You do see it is scanning across, so that actually might work. I don't know, but it doesn't automatically select 0.5. So this is 1 kilohertz, 0.5 volts. So it does read that frequency, 1.02264. So basically, if we take our probe here and we go ahead and hook it to our counter, we're in kilohertz. Then we go into hertz. It'll take a long time for it to really. You have to wait for the gate to flash. That's how many times it's counting or whatever. And it can be quite a bit. So we still basically have the same kind of reading. 10226. Not the kind of resolution of this oscilloscope here, but good enough. How often am I really going to read the 1 kilohertz? So we go up here. Let it flash a couple times. 1.023. We go up here. 1.03. Go to megahertz. That's megahertz, 100, 10, 1. That actually reads mega, 100, 10, 1. See, that's not very accurate. But it still read it. So the most accurate for this one is hertz. You can change the gate a little bit, and if you turn it all the way, it'll actually just hold it. But I don't like how slow it is. I wish it was a little bit faster. So anyway, that is working just fine. This one here has the same thing. 5 volts, 1 kilohertz. I don't have a signal generator of any kind, so I don't have any other way to do anything with this. But what I'm going to do is go ahead and try something else too, one of these other ones down here. So this one, it can't read it, no matter what I've tried. It just, like, won't read it. Not enough signal, I guess. This won't read it either. Let me see. Slow the gate down. Let's see how long it takes for it to flash. We'll let it count 2 times and see what kind of number it gets. And that's megahertz, 198 kilohertz. So this is definitely not reading at all. There's just not enough signal, I guess. I don't know. It's too bad they didn't make these to where they actually worked. So this scope has some very limited view usage. You know, 0.5 milliseconds. And it's about where, you know, you just... I don't think you can look at anything else. 0.1, 0.2, and 0.5. So I'm going to try something else just while we're in here doing this. Okay, we know there's a signal coming out of here. Wow, look at that. Okay, now we've grounded it. Now let's see if we can actually like look at our signal. It tells me what the signal is, okay? There's too much voltage here, but it is 1 megahertz. And it's actually more accurate than this one. So that is our reference from our counter. So if we come in here like this, now I'm not really sure if this will do anything, but auto set to show what it really wants to read is 0.2 microseconds. That's what it thinks it needs, but it's broken. It doesn't work there. So we can change the voltage for division, but that doesn't do any good. We'll change our time base. Point 2, 0.5, 1, 2, 5, 10, 20, 50, and then we see something at 0.1 microseconds. Now, it's like moving too fast or something, I don't know. We can't slow it down enough to actually see what it looks like. But if we try this on our other oscilloscope, we can look at it. Alright, we gotta wait for it to boot up or whatever. Okay, there we go. Okay, we've got a signal here. And we need to be, I should be at 0.5. But it sure doesn't look like it, does it? See how we get into it? Now, we're in a time base that I can't look at on the other one. At 1x, I guess we're looking at 5 volts per division. So this thing must be putting out about 5 volts per division. And it's kind of got like a... See, we're looking at more frequency. We're in the time domain, more time. So what are we at? We are at maybe 2 microseconds. Okay, so we look at... Or is it... It seems like it's the other way around, really. But this knob might be not in the right position. So I guess when we're doing this, we're actually slowing it down. Is that all the way? No. Okay. So that's 0.5 microseconds. And I believe where our other one works is at 0.5. So that's what we're looking at. We can go 0.1 to 0.5. You'll never be able to see that waveform because you can't change the time on the other scope, which is what makes it suck. If that scope worked, this would be an awesome scope, especially it's a 4-channel. And all the channels do work, and I've used the frequency counter, and it works pretty good, but the rest of it doesn't work. So basically I'm going to end up with a lot of oscilloscopes until I get one that really has the functions of this one. And let's see here. So basically you can zoom into it pretty far, but you won't see anything no matter what you do. It's just too fast to see the wave. You got to slow it down, I guess, or no. I'm not really sure. It's kind of confusing. And also I need to make sure that am I in the right mode. Source. A source. Internal. Okay. Channel 1. Vertical mode. Okay. Horizontal mode, A. Channel 1. Oh yeah, if you don't change some of these, this thing can get real weird. Anyway. So yeah, 5 volts per division is what it is. And it might show up on the other frequency counter now, because it's at 5 volts, the other one's at 0.5. Well, this thing just doesn't want to read anything. No matter what I do. It's like, okay. Why is it reading on 600? Something's wrong with this thing. The 200 megahertz scale doesn't work. It says pre-scale. I don't know what that means, but it does look like it works. It just doesn't work on the other scale. So is there something blown out in this thing I just don't know about? I'm waiting for the gate to flash. Look, it's reading it perfectly on this counter. But it does not work on 200. I'm reading 1 megahertz on the 600 scale. It's pre-scaled for some reason. I don't understand what that means, but it says pre-scale. And it's in pre-scale mode. It knows something's up. Let me turn this thing off, and we'll put it back on. Okay. We can't really seem to do anything with this input. I don't really know, and I can't find a manual for this thing anywhere. But it's not reading correctly. But as soon as I go to the 600, it reads fine. And if we go and pull this off of here, when I'm kind of curious, why does it say pre-scale? I don't ever remember it saying that before. Well, I did just drop the thing before I did this really hard. It like actually made some. No, it's just strange. It's really odd because now this is working too. I wonder if maybe there's something wrong with this thing. It was not working before at all. Okay, we've got one here. Now I'm gonna try something. Let's see. We remove this. Now it won't read anything. So that's normal. I got it in 1x. We take the probe and put it there. See, it's not able to read that. Yeah, it can't read it. And this one won't read either. We get 1 point something. I don't even know why they make these frequency counters if they don't work. I guess the only thing they're meant to do is to read the frequency of a transmitter. So like, just put it on top of your CB radio, and then you know when you're out of band. Like, I don't know what the point of this thing is. I mean, but here's a probe adjust signal, you know, on an oscilloscope, and it's not able to read it. But that can read it, I think. Can't remember. Let's try it. We get 0.958. Okay. 0.9. 0.01. It hurts. 1 point whatever. It'll change when the gate flashes a few times. It takes it a while to count when you have it on hertz. 9579. It's a little under 1. I have not tried to measure it on the other oscilloscope because I don't have 2 cords. But it does seem to be legit. Okay, let's try something different. That's certainly weird. We have 1 hertz. Reading off of its own reference. It does that. Is that normal? It's reading 1 megahertz here. Oh yeah, because this is 1 megahertz, so this is 1 kilohertz. So yeah, that makes sense. 1 megahertz still, with down to the 1 megahertz, 110, 1. So this reads to 100 hertz resolution. Okay, so we got with this one we have 100, 1000 kilohertz, and then 110, the tenths of hertz. And then we have here 1000 kilohertz, 100 hertz, 10 hertz, 1 hertz. So this is down to 1 hertz resolution. And then this might go to half. So we have a half. So it's going to bump out that other digit because we don't have it. Oh, I guess it does have it. Anyway, here's another little digit hiding there. I didn't see it. So that is 1,000,000 hertz. Or 1 megahertz. So there you go, guys. And this counter just seems to work. I don't know what's up, but I'm glad. So some of these other things are cool, but they just cannot read things. I don't know why that is, but they should be able to read this signal here, but they can't.